Uh, Good morning.
Morning, sir.
Morning, sir.
Morning. All right. Chapter 3, polymer processing. All right. As I've noticed, what else should I say? As I alert you earlier on, that this particular chapter will not be features in any of your tests or final exam.
Yes.
All right.
Yes.
So it's a little bit demotivated, right? But anyhow, for learning purposes, I think this is very important as well because polymer is widely used in the industry. However, there's one thing that I would like to actually call for your attention is that this particular chapter actually will features in one of your small individual assignment. All right. So this assignment will have a carry marks of 5%. Okay, which I will discuss later. All right. So we just have a very quick run through of this assignment of this chapter. All right. Now polymer as okay, is this slide is being shared? Can you all see the slide clearly? No.
No.
No, sir.
Okay, I think the sharing is gone. Okay. Okay, it's reappearing now. All right. So, all right. Okay. So, in this polymer, basically, we know that polymer is actually one of these material that is being widely used, okay, in every industry, simply because it has a very good properties. All right. Like for example, you can have different variety of colors in terms of products. You can have a very good strength to weight ratio. You can have transparencies of these materials, which somehow is difficult to be achieved by using other material, for example, like metal, and so on. All right. So it has a lot of these uh, properties, for example, like physical properties, mechanical properties, chemical properties, that is quite excellent. And it gives a lot of this option to this manufacturer to choose from. All right. So some of these, like for example, in the car manufacturing, as you can see from the interior and even exterior of these car parts, components actually is being replaced over the years with polymer or plastics. Okay, simply just to reduce the weight of the car and somehow do not compromise too much on these physical, mechanical properties, and so on because of its excellent properties. Now, plastic also can be machined, can be formed, and can be produced rather quite easily. Okay, if compared to some of these other materials. All right. So I can conclude that plastic is actually a very important class of material that is widely being used nowadays. Like for example, the casing of the phones, okay, this protective casing of the phone, okay, and some of the component, okay, insulators, and so on, and some of the casings, of these electronics parts, electrical parts, and so on, and some of the even some of the, let's say, this table fan, and it's being replaced widely a lot with this plastic material. So simply because one of it is to save costs, and then secondly, it does give an attractive appearances, in terms of the smoothness of the surface. It don't get rusty, okay, and then some of the weight is greatly being reduced, okay, and then it has a very good resistance to the environment. All right, but that would depends on how do you cook up the plastic in the process, right? So from where I learned this term? Oh yeah, I think it's from Jurassic World, right? When this actor said that would depends on how they cook up the dinosaur in the lab, something like that. All right, so that would be resulted in this how this final characteristic of this final material would be. So it is very important that you choose the right, okay, combination of material, okay, for your parts and component, and actually the right mixture of material to strengthen or to change the characteristic of this particular material. All right. So, for example, you can put plasticizer to make it easier to process. Okay, you can put in flame retardants to actually make it, less flammable. Okay, you can put in a lot like colorant, okay, pigment to actually change the color of the plastic. All right, so that if you want to have a red one, then you put the red color pigment. If you want to have the yellow one, you put the yellow one. Okay, and so on and so forth. And if you want, some of the plastic actually is transparent, okay, which is very good for, let's say, the packaging materials, which is very good for this, let's say, transparency slides, which is very good for this, let's say, this windshield, screen makings, and so on, which it has to be transparent because some of the protected shield on the machine, whereby you need to observe the process, and so on. So it has to be transparent. All right. So it would the highly depends on the performance and highly depends on the characteristic that is required and your application as well. All right. Okay. So yeah, it just indicate me my pencil is having low battery. Never mind. I just charge it and then within 10 or 20 minutes, 10 minutes or so, it will be about fully charged. All right. Okay. So so plastic, basically polymer, actually have this reflection on these advantages here. It mentioned here, it is a corrosion resistant or resistance to chemical. Okay, low electrical and thermal conductivity, low density, high strength to weight ratio. Okay, so it can be reinforced. So some of the plastic material actually they put in, for example, like this metal powder or wood dust, to basically strengthen it. So the principle is just like our on how the construction is, whereby they have the reinforced concrete, whereby this concrete, the cement, everything, there is a steel bar actually inside it to make it stronger, so that it can withstand tons of weight. Actually, especially when you are on the, let's say, the apartment, and so on, and this particular building is like 20 to 30 or even higher in terms of stories, and so on. So it can withstand the weight that is inserted on the foundation of this structure, because you do not want that whole particular building to collapse, after, you're building so 10 or more stories, and so on, because it just couldn't sustain the weight actually inserted on the foundation or even onto the walls or concrete or this structure especially. So like, for example, like solid mechanics, and so on. So they have to calculate all this, where you have these structures, the pillar is being built, and so on, to withstand the whole thing. So that's why when you do, let's say, the internal renovations, and so on, you just simply cannot, knock down a certain walls, and so on, because it might affect the structure of the whole building. So there might be causing crackings or even collapsing of the whole thing. All right. So noise reduction, wide use of color or choices of colors and transparencies is available. Like, for example, this let's say, in those spectacles. Okay. So you must have, the transparency, other than using glass, you can use plastics, as these flame materials, right? So ease of manufacturing, and then the complexity of design is possible, and then relatively low cost, and some more. One of the great thing is that some of the plastic, all right, can be recycled. Okay, that would make the actually the wastage, is very minimized, and so on. And some of this is more eco-friendly, even though some would argue that the most eco-friendly way is not using the plastic at all. Like for example, not using plastic bags, and so on, not using this, let's say these packaging materials, and so on. But somehow, sometimes this thing cannot be avoided. All right. So, but we would like to have this plastic so that even though we have to use it, but we like to have this option that this thing can be recycled. Okay, we can collect it back and then remelt it, blend it with the new materials and then reuse it back and then reinsert it into the markets, and so on. Okay, so some of the major advantage, okay, so over metal, okay, so the is that the usage of the in terms of manufacturing of these parts and component, the usage of energy is lesser, because one of it is because this metal actually has a very high melting point if compared to plastic, right? So about aluminum alloy, and so on, we are talking about 800 degrees Celsius or even more. Okay, depends on these formulations. And for plastic, it's just like a few hundreds, like 200-300 degrees Celsius, and some at 100 to 200 degrees Celsius. Okay, so that the lesser energy is being used to achieve or to produce the same parts. Okay, so in the long run, it will save us a lot of energy. So it is somehow more eco-friendly. Okay, in terms of if we use lesser energy and then lesser fuel is being burned, lesser resources is being used actually to produce this particular energy. Okay, to actually melt these particular parts for manufacturing. All right. So the amount of polymer can be accurately determined with negligible amount of waste. Okay, so that sometimes it does produces waste, but the wonders is that I can chip the plastic, whatever that is being for rejects or anything, I just can cut it into small pieces, and throw it back to the tumbler, and melt it again and reuse it. All right, even though there is a limitation of that, but somehow it can be. So we like the idea of things can be done. Okay, even though there is a limitation, but still we can actually recycle the material. Even some of these components or some of the product nowadays, especially in the packaging materials, sometimes they like to actually highlight it. Okay, recycle material is being used. Okay, so some of these like the boxes, and so on, they will use this recycled material partly just to save costs. Secondly, it's just like a jargon for this company that they are so eco-friendly, they are environmentally alert, and so on. So it become a very good campaign for them as well. All right, like some of these parts they are fully using this recycled material. All right, and they gain a lot of support over the years that they are being environmentally alert, and so on. So it start to become a selling point now, actually, nowadays. All right, so you have this range of mechanical properties, whereby the numbers, and so on. All right, so you have this megapascal, gigapascal, elongations, Poisson ratio, for all the material like ABS, and so on, anti-polyester, polyethylene, polystyrene, and so on. All right, you have a wide range of material that you can choose from. All right, so what is a polymer? All right, so we're talking about polymer or plastic manufacturing. Polymer basically, okay, from the word mers, okay, it means that parts, the smallest repetitive unit of something. Okay, so poly means a lot. Okay, polymer means a lot of mer. Okay, so with the combination or repetitive of mer being linked together is called a polymer. So it forms a certain long chain of mer or repetitive mer in the formulation or the molecular structure. So that is a polymer or that is a plastic. All right. So there are two types of plastic material that is a structure that is available. One is this amorphous structure. Okay, so in this amorphous structure, you can see that there is a cross-linking. It's like there's no one particular format or formation, okay, style or pattern. And for this kind of mer or polymer, basically it belongs to something like a very complex structure. So for a complex structure, it is very difficult to separate it. You can form it, but it's very difficult to separate it. So for this kind of let's say material, normally, okay, it is of something that you cannot be recycle. You cannot recycle. For example, like thermostat, natural rubber. Okay, so we would prefer something like the crystalline structure, whereby I can break this down into shorter mer or polymer, okay, or then I can break everything into individual mer, and then I recondition it, add in chloride, add in this, add in that, and then when crystalline again, they will rearrange themselves back into the certain polymer again. All right. So for this kind of material, normally, okay, it can be recycled as freely as you wish. All right. So you just have to know that there's such two kind of temperature that is this kind of structure which is available. All right. So this normally when material is forming, all right, so it has a certain glass transition temperature. All right. So the glass transition temperature is also called a glass point or glass temperature. Okay. So it is used in describing when it is solid, okay, it behaves in the same manners, okay. So it has a very small temperature. It's just like it is between, let's say, this solid and liquid. So how or what happened during the solid, the liquid phase actually, it what happened actually during that stage, when everything is being formed and slowly become solid, everybody is grabbing each other's. Now, everybody means here is the mer. The mer is grabbing each other's, okay, and form a solid state material, okay, so that it stay as solid as possible, it stay as stable as possible. What happened? It's just like this glass transition temperature, okay, in the metal, whereby the molten metal actually go through a phase. It will stay at one temperature for some times, and during that sometimes is the phase whereby all of these mer or all of these molecule or atom actually is grabbing each other and form a certain bonding in between them. Whether it's a strong bonding or a weak bonding, that would depends on the condition. That would be depends on the nature of that particular material. All right. So it's very important to actually know that that's why material science is very important, because you have to know or understand what's the nature of the material, what you can do with the material, what you can manipulate from the material, what can be achieved from that particular materials, and so on and so forth, before you actually decide what material you want to use for a certain parts. All right, that's very important. All right. So there are three types of polymer which is available. Okay, one is thermoplastic, one is thermoset, and one is elastomer. So thermoplastics are the one that we mentioned that it can be recycled. All right. So you have a lot of these thermoplastics which is available. Okay. So there are types, and every types of family, and groups basically has their own strength and weaknesses. Like for example, okay, let's say acetal, okay, so formed by adding the acetal and alcohol into the hydrocarbon, So it has a good strength, good stiffness, good corrosion to creep, abrasion, moisture, heat, chemical. So typically, you can use for parts like, for example, bearing, the plastic bearing, that you use for your toy car, those control car, and so on. So even though it might not be as good as the one that used in your car, okay, but those kind of high performance control car, for example, like the brands, I wonder if you know, it's called Tamiya. Okay, and this particular control car, basically, it costs maybe hundreds to thousands of ringgit Malaysia, and some of the parts like the bearing, the spring, and so on, everything is quite rather expensive if you buy it on spare parts. And that particular control car is run by fuel, okay, and normally it do not use our car fuel, it will use the jet engine fuel. That is the most expensive one. It would cost hundreds of ringgit for 1 liter of the fuel. All right. So if you want that, then you go for acetal. Okay. If you want something like polycarbonate, okay, let's say for one example. So polycarbonate, it has very good mechanical and electrical properties, high impact resistant. Now, let's say if I want to make, let's say, a helmet for biker. Okay, when you're riding a motorbike, you need to wear a helmet. So one of the things that the helmet is to protect our head, right? So when do we need to protect our head? So whenever there's an accident, and so on. So maybe besides, the motorbike banging on the car or the car bangers, and something like that. So the head might be, subjected to injury, and so on. So the helmet must be able to withstand a certain level of impact. Okay, so probably one of these material that you can choose is by using polycarbonate. All right. So other than that, okay. So okay, not so important here. So the following here is the type, still on the type of materials. Okay, still on the types of this plastic material that you can have. All right, and then we have this next one is on the thermoset. Okay, thermoset, as I mentioned, is on the amorphous structure. All right, it's not on the crystalline structure. So the structure of it is like, all messed up, hair wire, and so on, kind of structure. So once it is formed, okay, it is very difficult to actually recycle it. All right. So simply because that everything is so meshed up that it is impossible to separate it back to individual mold. Okay. So owing to this, okay, it is quite impossible to actually recycle. It means that the thermosetting material, I can't melt it and then I form something else. Okay, no. Okay, so you don't do that. But however, there is still a way of, if you want to recycle thermosetting material, yes, possible. One of the way to do it is actually I grind it into powder and then I mix it into the thermoplastics. I use it as the reinforced thermoplastic. All right, I can do that. Okay, or I grind it into not so powder, small pieces, small pieces. Then I mix it with the fresh thermoplastic. Then I can use it so as a reinforced thermoplastic. That is okay. All right. So, but other than that, you can't basically remelt a thermoset and reuse it for any other products again. Okay, once it is formed, that's it. Okay, so if it is subjected to heat, okay, so normally it won't melt. Okay, it will rather it's just like paper. If you burn it, it'll become ashes. It becomes something else. Okay, once become ashes, you can't basically use the ashes to remake the paper, right? So the philosophy actually is almost similar with something like that. You can't just actually reuse it in such a way. All right. So then you have this thing called elastomer. So elastomer is include something like natural rubber, synthetic rubber, silicone, polyurethane, and so on. All right. So nowadays we have these biodegradable plastics. Okay. So which is something with the eco-friendly in mind. So it is actually this kind of plastic can dissolve in water, and so on, so that it will not cause, like for example, a normal plastic component or plastic bags, even if you bury it under the ground, okay, it would take, okay, hundreds of years to basically decompose. Okay, it will become, hydrogen and carbon again in a few hundred years time. All right, so it would be very, uneco-friendly. Okay, so right now, even nowadays, we know that we can't actually reduce or get rid of plastics, so we are trying to reduce it. For example, instead of using shopping bags, okay, the plastic bags, so we bring our own shopping bag. Okay, instead of using plastic bags, we use paper bag. Okay, but one thing I hate about paper bag is that have you ever tried to order the Grab food or the Food Panda, McDonald's, and something? Okay, so when the food come, especially when you order drinks, right? So sometimes because of the drinks is not being covered properly, some of the drinks splash out, and wet this paper bag. So there's ones that I carry the paper bag on the top edge, and then the whole thing, because the bottom part is already so wet that it is broken, and then the particular cup actually fall down, and so on. So I don't like that. But however, not to say that I don't like the idea, just that somehow it is not so practical. If in case just that you use the paper bag to buy to wrap something else, okay, that is okay. Something like your burger, and so on, or magazines, and so on is okay. But something that is wet maybe is not so ideal. Okay, but anyhow, okay, so this is one of these things that is very important, especially when you look into plastic material. So if you happen to have a plastic bottle in front of you, you can flip it over and look at the bottom and see if you see something like this. Okay, so what does this mean? If it's number one, okay, normally it's on your mineral water, okay, the bottle of the mineral water. Okay, normally that is what we call as the PET bottle. Okay, polyethylene's bottle, and its rating is number one. So normally for this kind of plastic bottle, it is actually intended to be used for maybe one or a few times, and that's it. Because normally for this kind of bottle, it will not last long. Okay, so it's just for, after you drink the water and then you throw it away, or maybe you can refill once or twice, just for your convenience, and probably after that you need to throw it. It is not too chemically stable. Okay, it is not too resistant to, let's say, the environment, especially the ultraviolet, and so on. Proof of that is, okay, you can try to use this bottle. Okay, so when you came to the faculty, you park at somewhere, and then your car is exposed to sunlight, heat, and so on, and then you leave the particular bottle into the car and let it be for a few days, and then after that you reopen the bottle, okay, the cap, and then you start, smelling the water. It smells like plastic water. Okay, so means that some of these molecule in this plastic actually dissolve into the water. Okay, so that particular water is not healthy to drink anymore. Okay, so for, let's say, like baby milk bottle, if you want to make coffee with the bottles, your thermos, and so on, we do not recommend number one. We do not recommend number two. We do not recommend number three. We do not recommend number four. We do not recommend number six. We normally go for 5 and 7. Okay. Normally, this is for, let's say, repetitive use of hot water. Okay, for hot drinks, milk, and so on. But of course, the best is still using glass. Okay, as drinking, a cup, and so on, or thermos, and so on. Still better to use glass. However, actually, glass has one disadvantage. Glass basically is easy to break, right? Okay, so there are pros and cons, right? So, but however, glass is one of the best things. So if you can see that the normal glass bottle, okay, provided by this manufacturer, okay, so actually they use paper boxes, okay. When you're buying this kind of milk or carton drinks, and so on, they rather use paper rather than plastic. Why is that so? Okay. So there are reasons in using that. It's just like sometimes, okay, you might wonder, okay, like for example, a refrigerator. No, when you normally there are 2 doors, right, for the normal one. Okay, so in the bottom compartment, normally if you open the door, okay, there'll be light. Okay. So that it's easy for you to find things, whatever that is inside there. But how come there isn't any light for this frozen food compartment? It's just about, right? It's just about. You just put a bulb there, light up, easy for you to find things also. Why they don't include that? There must be a reason. Okay. Okay. So part of the reason is that, okay, normally depends on the time that you use for that particular product. For example, the refrigerator. When are you opening up this top compartment, the freezer compartment? Normally it's during when you are cooking. Okay, so normally if daytime, you don't need that light. Even if it's a night time, normally your kitchen light is on. Okay, so you basically do not need any bulb in that. But why do we need a bulb at the bottom? Because sometimes during late night, you wake up in the night, you just go to the freezer and get a carton of milk to drink. You don't have to on your kitchen light. That's the reason. That's the let's say this they did it on purpose. Okay, they did it on purposely, because on how or when are you going to use it? Okay, so they include the light on the bottom compartment and not the top compartment. So normally when cooking, normally your kitchen light is on or during the daytime. Okay, so you don't actually need the bulb actually inside. Okay, and the bottom compartment is during midnight, and so on. You just feel like, you wake up from the bed, can't sleep, and you want some drinks. You just go to the kitchen. You just go to your refrigerator and open it. There is a light. It's easy for you to find where is your milk carton, and so on, so that you don't have to on the kitchen light. All right. So there are some of these additive basically is needed that is being added into this polymer. So one of it is called this plasticizer. So this plasticizer is to make a plastic behave more like a plastic, to make it flow like a plastic, to make it form like a plastic. Okay, just like a woman's wearing a dress that best bring out her feminine side of a lady. Okay, so like wearing high heel shoes, wearing makeup, and so on, to make this more feminine. All right, so This plasticizer actually acts more or less the same way to make it behave more like a plastic. All right. So another one is the carbon black. Actually, is being added in to enhance this resistance to this environment, to be able to withstand ultraviolet, to withstand a certain radiation from this environment, especially from direct sunlight, so that some of this equipment that you put outside the house, okay, actually able to withstand, the day and night, exposure to the sunlight, and so on, so that the degradation of plastic will not happen too quickly. All right. So you have filler material. So filler material is basically added into the plastic as a filler, so that you don't have to use so much plastics. Okay, so ever wonder why some of these, let's say the washing powder, like for example the Attack 1 kilo, it costs something like RM 20 ringgit, and then another one, the Economy or something like that, 5 kilo, and it costs just like 10 ringgit only. Okay, and last time, because I want to save money, when I graduated, I don't have much income, I have this commitment, that commitment, and so on. So I normally go for the more economy type of groceries, and so on. I noticed one thing, that every time I wash my clothes, especially with washing machine, some of my pockets, so when I'm clearing the pockets, always something that feels like tissue paper is in my pocket. So where does that come from? Is the filler material in this washing powder. So they add in the filler material simply because they want to make the package, looks bigger in size. Wow, 5 kilo, 10 ringgit only. And this one, 20 kilo, 20 ringgit, 1 kilo only. Even you say you use one scoop will do. This one I can, with this one I can, no, with, with this one I can pour as much as possible. Okay, I can pour as much as possible, and then I see a lot of bubble. I feels like it's very clean. So that's the psychology, right? Okay, so this filler material basically, in another words, is to reduce the plastic usage. All right. So in the end, you just produce something that is having these shapes, having this size, and so on. It doesn't matter. For example, your pail, that is being used in the kitchens, in the toilets, and so on. It doesn't matter as long as it's whole water. Okay, your, let's say, the dustbin, that you use, since it's black color, since it's black color, it's big, and so on. Doesn't matter as long as it's strong enough. Okay, so I don't mind what kind of filler materials that is being put inside, since I just use it to throw rubbish only, right? Okay, and as long as the product price is not so expensive, okay, then you have other things like colorant. Colorants means that it increase the variety of the products that you can use to have various colors, that you can choose from. Then you have flame retardant. So to make it flame retardant means that it is not actually reactive to fire. It will putting off the fire by itself. If you burn it, you burn for some time, then after some time it just put off by itself. Okay, so a lot of these recent years, actually, the electricals, and so on, they have this kind of flame retardants, so that in the end there won't be a lot of, let's say, fires, and so on, due to short circuits of these electricals, and so on. So that's why more like modern kind of house, you don't have these problems. So normally it happens to a lot of these, factories, old factories that is, decades ago, a lot of their plugs, and so on, might not be this kind of let's say, material. Okay, they don't have this kind of philosophy back then to have flame retardant added in. So once there is a short circuit, everything is start creating fires, it won't put off by itself, and so on, and then the fire merebak, and so on, and then the whole factory basically is burned down. Okay. Then you have this lubrication. Okay, so this lubrication actually is being added in for better surface, and so on. The surface looks shiny, the surface looks smooth, and so on. And also for the easy removal of material during the process, because it is lubricated. So it won't stick to the mold, it won't stick to the devices that actually used to produce it. All right. Okay. So you have a lot of process basically involved here. Some of this process basically it will be actually discussed again. All right. So for this process, I don't intend to go too much further into it. So I'll just do a quick one. Okay, do a quick one here. So from page 15 to 22. So these are the process that is commonly being used. For example, compression molding. So in compression molding, whereby this plastic, okay, is being heated up into the glass transition temperature. Now, during this glass transition temperature, it is neither liquid or solid. It is something like a jelly form. All right. So it's not yet plastic and not yet liquid. Okay. So once you put it, you place it in the center here, you have this upper mold and the lower mold, and then you squeeze it. Then it will change. It will be forced to change the shape of this plastic and start taking up the shape of this gap, and then you eject it, you get your, let's say, your plastic cup, for example, okay, or your plastic container. Okay, so this is a compression molding. So in this metal forming process, we have something similar, we call it stamping. Okay, so the philosophy is more or less the same, but we'll discuss further on that, okay, in this following subsequent chapter. All right. So another one is the mostly used nowadays is called the injection molding. So the injection molding, we feed the material normally is in the billet form, okay, granules, okay, so it's in small pieces of plastic. So this plastic basically being placed into it, of course, mixed with all this carbon black, and so on. So they have the tumbler to basically mix it, blend it, and then they pour it inside here. So here it will fit into the system. So it will be lit by this lead screw. So this lead screw will actually travel and then push the plastic to the front. And meanwhile, on the way of moving forward, so it will be heated up by this subsequent heater. Okay. So when it reaches here, okay, so this is the staging up. Okay, so the temperature actually increase over the journey. Okay, so it's slowly heated up. When it reaches the front, it is fully melted. Okay, so the rest is just like squeezing the toothpaste from the toothpaste tube, whereby it will be squeezed out, in terms of something like a paste, something like that. And then when this mechanism, the mold close down, okay, so this raw material will start filling up here and then start making up the space, just like what happened here. Yeah, it will start taking up all this space, and then once it's cooled down, you open the mold and then you get your products. So that is the injection molding machine. All right. So other than that, so we can make a lot of products from here. So a lot of this injection molded process. Okay. So part of this, let's say, Like for example, this one. This is definitely a injection molded parts. Okay, wait, just wait for a moment. Can you see that? How come it's not showing? Okay, okay. For this one, this is definitely an injection molding process. Okay, parts product. Okay, whereby this is from a multi-injector, so that you can have various color, the yellow, the blue, the red, is in one piece. All right, it's in one piece. So for this kind of, let's say the toys or the model kits, you need to cut down pieces by pieces, and then you combine it together to form, let's say, robots that is indicated in the box, so on. Okay, so this is from an injection molding process. So what else? Actually, there's parts. Okay, the parts, as you can see from this thing, there's a small parts that you need to extract it out. But however, there are this kind of frame. Okay, so this frame basically can be recycled. Okay, you cut it back into small pieces and then you feed it back. You feed it back here. Okay. You can feed it back here. Okay, feed it back to here. You can cut it into pieces and then you can feed it back into this system, so it can be reused again. But however, there is a certain limitation of doing that. So you can't basically just put in 100% of the recycled plastic. No, they don't actually practice that. Okay, normally it will be something like 90 to 10%, or 10% of recycled plastic, and 90% fresh one, or 80 to 20, because it's going to affect the quality of the plastic. Okay. Because the plastic that you recycle generally is not a pure plastic granule. It's something that is being added with something else already. So it's just like, the second-hand things, normally is not as good as the new one. Okay. But 90 to 10, probably we can sacrifice, or we can still okay, acceptable, but depends on what kind of product are you making, and what kind of quality are you expecting. Okay, because some actually we do not expect high qualities, and so on. Like for example, you are buying plastics materials or plastic product from a Ringgit Malaysia tool shop. Okay, say let's say the flower pot that is made from plastics, basically you don't have too high expectation from that, as long as it hold the it hold the flowers, and so on, that will do. Okay, as long as looks nice. Okay, doesn't break rather too easily, still okay. Okay, so other than that, this one is not so important. Okay, so we have this extrusion. So in the metal forming process, we have the extrusion process as well. So you still have this, just like this injection molding, you still have these feeders, okay, whereby you put in your materials, and here, and then you have this lead screw to basically, it will move here, here gradually, okay, being heated up gradually. Okay, once it reaches here, it becomes fully liquid, and then it is being squeezed out from this mold. So once squeezed out, okay, it will take the uniform shape. Let's say if this one is something, if this mold is something like this, okay, so you will produce something that is like this. It's in the tube form continuously. So you are making, let's say, like this plastic tube. Okay, like for example, you are making this plastic billet, okay, and so on and so forth. So you can make from all this. So we will talk about this later. It's a very similar process. Okay, just that is metal. This is plastic. Okay, we will talk about it again. All right, in the subsequent chapter, which is in the metal forming process. Okay, so this is blow molding. So blow molding actually is by using this is something similar. So before this, it is something like this in the extrusion, whereby they produce similar thing, but it's in a very thin manner. Okay, then they close these two things. Okay, and then they form something like that. Okay, and then they'll blow air. So this thing will be blown and take the shape. And then when you let it solidify and then you open it, then here you get your plastic bottle. Okay, so it's called blow molding process. Okay, so you have centrifugal. So let's say if I have a mold, something like this, and then I pour in the plastics here, so it will start taking out it will start depositing at the bottom. So I spin this at a very high speed. So in the end, all the plastic will be running along this thing. Okay, just like this. Okay, you will running all around this thing. So and again, this thing we will discuss in the metaforming. You're running around this thing, and slowly when it cool down, it will start to take because of the centrifugal force. Everything is thrown to the side, not in the center, no, thrown to the side, and then form a thin wall on the mold. Okay, so it will take, it will form something like this. So probably it will be something, something like this. All right, it will form something like this. All right. So vacuum is we put is this thin film that you produce, whereby it is being heated up to the glass transition temperature, and then you apply the vacuum, and then this whole thing will be sucked down, and then start taking up the bottom or the shapes of it to form, let's say, casing, or something. Okay. All right. So basically, that's it for this chapter. So sorry to take your extra time. I wonder if you have some extra time so that I can spend a few minutes to talk about the assignment, or you have another class after this.
I have class, Doctor.
Have class
Okay.
later.
Okay. So you have class. So I think like this. You can leave for the class. For those of you who want to stay, you can stay. You can leave for the class, for your class, next class. I will continue to explain about this assignment. And later, when I post the video, you just drag until this assignment part, the final parts of it to see what I discuss here. Will that be all right?
Can Doctor.
Yeah, since it is recorded. So I have the luxury of doing that. So you can actually view it back later. And then for those of you who don't have class, you can stay back and listen to my explanation. All right. For those of you who have class, please go to your next class. All right. So I will share my video after when it's being done. When it's done. All right. All right. As for the assignment, so as mentioned that this is the personal assignment. All right. So it will be 5%. Okay. So what you have to do is that there is a list of assignment that you have to do. Okay. Now, not that a list of assignment you have to do, the list of title that you can select from. Okay. So here, let's say biocompatible polymer. Okay, biodegradable polymer. So it is a general topic, right? So maybe you can use biodegradable polymers for packaging material. You can actually refine your area of discussion. All right, like for example, injection molding of, let's say, of a plastic container. Injection molding for let's say a model kits, something like that. You can further refine, so you do not have to stick 100%, because if you want to talk about injection molding, it will be a huge topic, and then it can be involving a lot of this possible material, possible products, and so on. So you can refine it. Okay, so let's say high temperature plastics for, let's say, aerospace application, something like that. Okay, let's say for this one, high performance polymer for automobile. Okay, so you can go for that. It doesn't matter. So if because as I understand that here is there's about 43 title. Okay, so I will. So next what I want you to do is that you can choose the topic. All right, you can choose the topic by putting up, in the group. Number one, Richard, I'll be taking number one, and then who else want to be number 2, 3, 4, 5, 6, and so on. You go ahead. Okay, fill up all 43 first. Fill up all these 43 first before the repetition of this. Okay, so it happened that okay, more than one people want to do number 7, as long as these 43 haven't finished yet, you can't do that. Okay, number 44, only you can choose the repetitive one. Okay, means that there is no repetition for the first 43 persons. Means that you fill up this 43 first, number 44 onwards, then only you can choose whatever that is being taken. But however, try to make it different. Like, let's say, if one is doing extrusion molding for, let's say, 1, then another one have to do extrusion molding for something else. Okay, it has to be slightly different. All right, so what you have to do here is search relevant references and study the given topic. Okay, so it can be from my notes, it can be from the internet, from journal, from books, no problem, and from articles, from newspaper, news, and so on, no problem. Prepare a PowerPoint presentation, about 10 to 15 slides. So the submission is in PPT. Okay, PowerPoint slide. Okay, so can be more or less according to your preferences. All right, so 10 to 15, just a guideline. Okay, so that you don't write too little and then you don't write too much. Okay, because sometimes a lot of students they have this motivation to actually want to do more. Okay, not so basically it can be you can do more, no problem. Okay, but just as a guideline, I would say that 10 to 15 pages should be more than enough. All right, so list the references including in the presentation slide. Okay, you are encouraged to include illustration, video, animations in the slide. So assume only video is usable. Okay, so for your presentation, so it is said that you have to do presentation, but that would depends on if we have time for that or no. All right, so that's why I'm actually speeding quite a little. Okay, sometimes I just do self recordings, and then I'll let you so that our progress, okay, is faster. It's a bit faster than the normal time schedule. As you know, sometimes Malaysia there's a lot of holidays, right? So sometimes okay, you can't have lecture. Okay, you holiday. Okay, maybe sometime I'm sick, and so on. And sometimes there's special day, special event in the university. So then we can't have the class in our normal times. So I would like to go a bit faster in the beginning so that we will have the ample time during the end, okay, for our normal class activities. Okay, so the score will be based on the resourcefulness of the presentation style. So presentation style is like how nice is your slide, how well do you present the data you use, how relevant is your data, how useful is your data, and so on. But however, normally if you do your job properly, so it will be five marks. Normally you will get 4 point something, no problem. The previous student basically get 4 point something at least. Okay, so all right, so the submission date actually currently set as at the 16th of December. Okay, so this one we will actually I'll actually let you know more on where to submit, and so on. I'll give you the link later on, and so on. All right. So before the submission, what you have to do is that you have to send it to the turning in. Okay, turn it in. Okay, turn it in, and then make sure it's below 35. Not more than 40, and then this you must include your submission in as a proof. Okay, Okay, so that you means that you already check it, you get the results, you include your result in your submission as well. All right, so to prove that you are below 35% of similarities, and so on, that this is pretty standard. Okay, so the submission name, and so on. So it's like this. All right. Okay, so if your name and then you underscore section, let's say section 1, 2 or section 9, 10, for this semester. Okay, so it's in a PPT format. All right. So I think basically this instruction is quite clear. So the Turnitin's portal is being made. Okay. So there's enrollment key and the class ID actually is included. So you just log in and then submit it for checking. All right. So I think that's all for now. So meanwhile, okay, browse through these 43 topics that is available. Okay, I will share this information in a minute. All right. So you just share this. You just go through this, and then you just put up a list. On okay. Let's say Richard, I will take number 7, and then I'll leave blank for 1, 2, 3, 4, 5, 6, 7 at Richard, something like that, so that I know that it is taken by who and so. Okay. All right. So I think that's all for today. So I'll see you again tomorrow. Okay, for the tutorial session. Thank you very much. Have a nice day.
Thank you, sir.